Hello students, welcome to today's lecture on artificial neural networks. In our previous class, we have discussed about error correction learning, second one. Till now, we have discussed two learning rules. One is Bayesian learning rule, and the second one is error correction learning rule. Now, this is competitive learning rule is the third learning rule. Discuss it today as part of our lecture series on ANN. Competitive learning is a rule based on the idea that only one neuron from a given iteration in a given layer will fire at a time. That means uh, in a particular layer, there are number of neurons available. Only one neuron out of all those neurons can be activated at a time. And all the remaining neurons will be uh, generating an output zero. Means weights will not be adjusted. Only one neuron fires out of all the neurons from a particular layer. So that is the uh, main concept in competitive learning. The neurons in a particular layer competes each other, and the winner, whichever neuron wins based on some criteria. Let us say the criteria may be the weighted input is largest. The winner is updated, is able to update its weight, and all the other neurons will not be able to update its weights. Okay, that means only one neuron out of many neurons from a particular layer will be able to update its weight, or we can say that it flies. Okay. So this is a simple introduction to competitive learning. We can represent this competitive learning rule mathematically as Wij of n plus 1, that is the new weight connecting the xi to jth neuron is equal to old weight plus the difference between weights, where this difference in weight Wij, delta Wij of n will be calculated using the formula eta into xi minus Wij if the neuron Yj fires. This is not actually correct. If I is equal to j is not correct. If Yj wins, if the neuron Yj wins, then the formula is this. Delta Wij is calculated as eta into xi minus Wij. If it loses, then delta Wij is going to be 0. That means the weight will not be updated. Okay. So we'll understand this formula in a better manner when we look at the example in our later slides. So let us consider an example. We'll try to construct a competitive learning neural network for these input vectors. 4 input vectors are given: 0, 0, 1, 1, 1, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 1. As you can see, there is no desired response over here. That means competitive learning rule is a unsupervised learning methodology. Okay, it comes under unsupervised learning paradigm, right? And we need to assume a few parameters over here. The learning rate eta is equal to 0.5. It is assumed as 0.5. You can take any value between 0 and 1. The number of clusters, that means the number of neurons that competes each other in the output layer, is going to be 2. The number of clusters is given as 2. Okay, this information is given, this value is assumed, and these are the input vectors. And now we'll try to design a competitive learning neural network based on this information. The structure of the neural network we are going to build is like this. These two are the output neurons, O1 and O2, and there are 4 input values. That means the size of input vector is 4 here. Each input vector size is 4. Therefore, we need to assume these as x1, x2, x3, x4. So you can see it in the diagram. x1, x2, x3, x4 are the inputs connecting to these 2 output neurons, O1 and O2, with weights W11, W12 from x1 to O1 and O2. Similarly, X2 connects with O1 with W21, X2 connects with O2 with W22, and so on. The final value, let us say induced output from this neuron is going to be V1, and induced output from this neuron is going to be V2. Okay, so we'll calculate V1 and V2 as induced outputs, and we will identify which neuron wins. Based on that, we will update the weights of the corresponding neurons. Okay, so the step one initializes the weight matrix to some random values between 0 and 1. And if you look at this diagram, the weights are W11, W12, W21, W22, W31, W32, W41, and W42. So we need to initialize them as W11 is 0.2, W12 is 0.9, W21 is 0.4, W22 is 0.7, and so on. These are some random values. There is no specific criteria to initialize these values. You can pick any random number between 0 and 1. Okay, so after initializing this weight matrix, we need to calculate the induced outputs V1 and V2 for each input vector given over there. So we are given with 4 input vectors where each input vector size is 4. So we are going to calculate the induced outputs V1 and V2 for each of the input vector given there. So let us start with the first input vector 0, 0, 1, 1. Okay, so you can see it in example. The first input vector is 0, 0, 1, 1. Okay, now for 0, 0, 1, 1, this is x1, this is x2, this is x3, and this is x4. The induced output V1 from O1 is calculated as V1 is equals to, the formula is x1 into W11. You need to understand this through the diagram. X1 into W11 plus x2 into W21 plus x3 into W31 plus x4 into W41. The input and the corresponding weight connecting this output neuron over gives us V1. Okay, so in that manner, we will calculate it as x1 into W11 plus x2 into W21 plus x3 into W31 plus x4 into W41. So we substitute the values. X1 and x2 are zeros, therefore these two terms become zeros. 0 plus 0 plus x3 is 1, 1 into W31 is 0.6, you can see it. Okay, and x4 is 1, and x into W41, 41 is 0.8. So 1 into 0.6 plus 1 into 0.8, the value is 1.4. So the induced output from output neuron O1 is 1.4. Similarly, we will calculate the induced output of V2 also by using the formula x1 into W12 plus x2 into W22 and so on. First two terms are zeros. The remaining terms are 1 into W32. W32 is 0.5. W42 is 0.3. So it becomes 0.8. 0.5 plus 0.3 is going to be 0.8. So the induced output from output neuron O2 is represented as V2 is equals to 0.8. So V2 is 0.8 and V1 is 1.4. So which one is bigger? V1 is bigger than V2. Therefore, output of O1 is Y1. So Y1 is equal to 1 and Y2 is equals to 0. That means the first output neuron fires, whereas the second output neuron will not fire. Based on this, we will calculate the change in weights using the formula delta Wij is equals to eta into xi minus Wij if Yj is the winner. Otherwise, it is going to be 0. So which one is winner here? Y1 is winner. Therefore, delta W11, delta W21, delta W31, delta W41 will be updated, and delta W12, delta 22, delta W32, delta W42 will not be modified because it is 0 only. Okay, so we'll calculate it. Eta is assumed as 0.5 at the beginning. It is initialized like that. Into x1 is minus 1. It is 0 minus Wij, that means W11 is going to be 0.2 from the weight matrix. Now this is going to be 0 minus 0.2 is minus 0.2 into 0.5 will become minus 0.1. Similarly, we will calculate delta W21, delta W31, and delta W41 also using the formulas here. And delta 1 to W12, W22, delta W32, and delta W42 are zeros because the neuron, the second neuron O2 is not 5 delta, Y2 is 0. Okay. Then update the weight matrix with the help of this delta Wij calculated. So Wij plus delta Wij. That means, as you can see, these values are updated because the first neuron is the winner, and these values are unchanged from the original matrix. Okay, so you can see it. Initially, the weight matrix is 0.2, 0.4, 0.6, 0.8. These are getting updated. These are unchanged in the resultant weight matrix. Okay, so how this is done? The existing weight, okay, the existing weight, that is 0.2 here. This is 0.2, and delta Wij at the corresponding position is minus 0.1. So 0.2 minus 0.1 is 0.1. Okay. Similarly, we calculate the second one, third one, and fourth one. These are the values, and these are unchanged. So at the end of one iteration, by considering the first input vector, weights were modified. Okay. Similarly, we try to calculate the induced outputs V1 and V2 for the output neurons O1 and O2 by using the second input vector, that is 1 0 0. Okay. So just like we did it with the first input vector, we are going to do the same process for the second input vector also. So now x1 is 1, x2 is 0, x3 is 0, x4 is 0. So V1 is calculated as x1 into W11 plus x2 into W21 and so on. As x2, x3, x4 are zeros, these three terms become 0. So 1 into W11 in the weighted updated weight matrix, it is 0.1. So 1 into 0.1 is 0.1. V1 is 0.1. Similarly, we calculate V2. 1 into W12, that is the only term we'll consider. W12 is 0.9. So it becomes 0.9. Now, if you compare V1 and V2, which one is the winner? V2 is bigger than V1. Therefore, V2 uh, representing the second neuron becomes the winner. So Y1 is 0. So Y2 is 1 and Y1 is 0 because the second neuron is the winner. Okay. Since V2 is greater than V1, Y2 becomes 1 and Y1 is 0. Now, based on this, we'll calculate the change in weights, delta Wij, by using the same formula for the winner neuron. That means here Y2 is winner. So for the second neuron outputs, we'll calculate this. There is no change in delta W11, delta W21, delta W31, delta W41. They all become 0. Okay. And the remaining weights, that is delta W12, 22, 32, and 42 gets updated by using the formula n into x1 minus W12. Okay. Why we are updating these weights? Because the second neuron is the winner here in this case. Okay. So at the end of this, we got these values. We use the formula Wij is equals to existing Wij plus delta Wij, these values, to find the resultant changed weight matrix or updated weight matrix. Now it is, there is first column unchanged now, second column is changed. Now we got 0.95, 0.35, 0.25, and 0.15. In step 4, we consider the third input vector 0, 1, 1, 0, and we proceed the same process. We calculate V1. It is now 1. and we calculate V2, it is 0.60. It can be easily observed that V1 is greater than V2, therefore Y1 is 1 and Y2 is 0. Therefore, W11, W21, W31, W41 are updated using the formula eta into xi minus wij. These are the values calculated. And W12, W22, W32, W42 are zeros. Okay. The changes in weights are 0 here. We'll update the weight matrix using the formula again. Wij is equal to existing Wij plus delta Wij. Now we can observe that the first column gets changed now because y1 is 1 and y2 is 0. Therefore, the second column is same as previous iteration. Okay. And in step 5, we consider the fourth input vector 0001, the last input vector. We calculate v1. Now it is 0.45, and we calculate v2. It becomes 0.15. Now we can see that the winner is v1. Therefore, y1 becomes 1 and y2 becomes 0. Therefore, w11, w21, w31, w41, W41 updated weights will be adjusted weights will be calculated here. These are minus 0.025, minus 0.3, minus 0.5, and minus 0.275. It can be easily identified that W12, W22, W32, and W42 are zeros. Okay, because Y2 is 0. That means the first column gets updated with the corresponding delta Wij, and the second column is unchanged compared to the previous iteration. Okay. So this is the final weighted matrix: 0.025, 0.95, 0.3, 0.35, 0.45, 0.25, 0.175, 0.15. Okay. With this, because all the input vectors are used to build the neural network, the process is completed, and these are the final weights that connects the neural network. That means you need to see. We calculated these values: W11, W12, W21, W22, W31, W32, W41, W42. Once these are identified, it means the design of neural network is completed. So for any given input vector, based on these final weights, we will be able to identify the actual output that will be classified as either this neuron. If this neuron fires, it will be considered as a first class or classifier 1. If this neuron fires, it will be categorized as a classifier 2, second category. Okay, so basically competitive learning is useful for building classification problem applications. Okay, so that is the first example we have gone through. I hope you understood it. Now here is an exercise to check your understanding. You need to construct a competitive neural network. Remember this name, winner take all network. Either you can call the network as winner take all network or competitive learning network. Both are same. For the input vectors 101, 010, 110, and 001. Observe the difference that the size of input vector is 3 only. That means for the neuron, there will be 3 inputs, x1, x2, x3 only, and the number of input vectors given is 4. Therefore, you need to perform 4 iterations by considering each input at a time. Okay, and you need to assume the weights, learning rate. This is not correct. Weight is not correct. Assume the learning rate as eta is equal to 0.3. It is given here, and the number of clusters is again 2. So it is a two-way classification problem for these inputs. Okay, and I'm giving you a hint also about the structure of the neural network. There are 2 output neurons since the number of clusters is given as 2, and the size of each input vector is 3. Therefore, there is x1, x2, x3 connecting these two neurons. So the weights are W11 connecting from x1 to O1, W12 connecting from x1 to O2, W21 connecting from x2 to O1, W22 connecting from x2 to O2, W31 connecting from x3 to O1, and W32 is connecting from x3 to O2. So you need to perform the same kind of operations by calculating the induced outputs V1 and V2 from O1 and Y to O2, and then identify what is Y1 and Y2, the final outputs, and update the weights accordingly based on whether Y1 is 5 or Y2 is 5. And after completing all the input vectors, you will identify the final weight matrix. This is the final answer that should be identified. So this is given for your reference. Do it in your home and verify your answer with this. Okay. Oh, sorry. This is actually initialization of weights, and this is the final output. This is the final output. You need to identify. You need to verify your answer with these values. Okay. Initially, the weights are initialized randomly like this. The final, after completion of fourth input vector, you should get these values, and this is your final answer. Okay. Here is a simple comparison between the learning rules. The three learning rules that we have discussed till now: Hebbian learning, error correction learning, and competitive learning. In terms of four factors here, the first criteria is weight initialization. Weight initialization is done to 0 in Hebbian learning. Uh, in error correction and competitive learning, the weights are initialized to random values between 0 and 1. And weight change is calculated. Delta W is calculated in Hebbian learning using the formula xi into y. Whereas in error correction learning, it is delta W is equals to eta into error signal into xi. In competitive learning, it is calculated as delta Wij is equals to eta into xi minus Wij for the winner neuron. And updation of weights, obviously this is going to be same formula in all the learning rules. New weight is equals to old weight plus the change that we have calculated. Okay, in all the cases, the formula is going to be same. And the learning rate, there is no learning rate used in Hebbian learning. In error correction, learning rate is initialized to some random value between 0 and 1.